Hello, everyone, and thank you for joining us for today's webinar, A Revolutionary Pipe Technology, Steel Reinforced Polyethylene. Before we begin today's presentation, we wanted to cover a few housekeeping matters that will ensure you have a good experience. At the bottom of your screen are multiple application engagement tools you can use. All the engagement tools are resizable and movable, so feel free to move them around to get the most out of your desktop experience. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. Helpful resources are bookmarked in the related content tool. Our webinar today is scheduled to last for 1 hour and will include a question and answer period. If you have a question, please type it in the question box at any time. Please complete our brief survey for PDH credit, and at the conclusion of today's webinar, I will provide more information on how to get the PDH certificate. Today's webinar is hosted by Justin Walton, Andrew Jenkins, and Ryan McCaslin. Justin Walton is the Pipe Area Manager for Contech's Southeast, Mid-South, and South Central regions. Andrew Jenkins is the Pipe Area Manager for the Great Lakes and Atlantic regions, and Ryan McCaslin is the Pipe Area Manager for the Great Plains in the West. Now I'll turn the presentation over to Justin to get us started.
All right, thank you, Jill. Good morning, everyone. Hope you're having a great week. We are glad that you're here. We appreciate you taking time to get better acquainted with steel reinforced polyethylene. Quick look at our agenda. I'm going to give an introduction to steel reinforced polyethylene, talk a little bit about how it's manufactured. Then I'll pass it over to Andrew, who will talk about storm drainage and sanitary sewer conveyance solutions. Then I'll get into our containment tanks, and Ryan McCaslin will share information about trenchless structural reline. And then at the end, we'll wrap it up with some resources that are available to you. So as you can see, steel reinforced polyethylene is a very versatile material. It has many different applications, and we hope to touch on a few of those today. If you're not familiar with Contech, our company is a nationwide manufacturer of products for civil site development, primarily drainage. We group our products into 3 categories: stormwater solutions, pipe solutions, and structures solutions. Stormwater solutions would include BMPs to pre-treat and treat stormwater runoff, things like hydrodynamic separators such as CDS or Vortechnics or StormScepter, as well as filtration devices such as StormFilter or Jellyfish Upflow Filter, to name a couple. We also manufacture subsurface stormwater detention and infiltration systems. Our pipe solutions group would include corrugated steel and aluminum pipe, thermoplastic PVC pipe, as well as steel reinforced polyethylene that we'll share today. Finally, our structures solutions group would include steel and aluminum structural plate. It comes in many different shapes and sizes. You may have heard of Conspan or BIBO. These are precast concrete bridge structures that we manufacture, and they get up to about 102-foot clear span. We also manufacture steel truss bridges for pedestrian and vehicular applications. So next month will mark the 1.5-year point since the Infrastructure Investment and Jobs Act was signed into law on November 15th, 2021. A few reports that I've seen from large engineering and construction companies are indicating that funding is increasingly making its way from the design phase to the construction phase. And curious what you guys are seeing. If that is something that you're seeing, please feel free to leave a comment in the chat box. Let us know what you're seeing. But this, along with the AIP, the Airport Improvement Program, and last year's Inflation Reduction Act and CHIPS Act, will hopefully play a part in needed growth and development for our country's infrastructure. That said, the SRPE solutions that we'll share today are viable options, particularly for the civil site aspect of many of these projects. It might not surprise you to learn that Contech's steel pipe roots go back well over 100 years, but you may be surprised to know that this year marks the 60-year anniversary of our plastic pipe solutions. Going back to 1963, we developed truss pipe. We also manufacture SDR 23.5 solid wall, and A2000 was developed in 1984 in 4-inch through 36-inch. And it was not long after this that Contech realized a need to develop a larger diameter pipe that checked a lot of the same boxes as A2000. A smooth interior, a watertight joint, a 100-year service life, the ability to handle heavy live load. And that's where steel reinforced polyethylene comes in. SRPE is the industry acronym. DuroMaxx is Contech's brand name. And this essentially takes the best of both worlds. It takes the attributes of steel, the high strength, the high load carrying capability, the ability to handle heavy live load, and it marries it together with the attributes of quality HDB rated polyethylene, the ability to have a smooth interior, a watertight joint, and a 100-year service life. And this technology allows us to go from diameters starting at 30-inch all the way up through 120-inch. So it gets very large. And this technology was originally developed in Australia and Asia, and Contech brought it to North America in 2007. And the idea is to replace most of the resin in the pipe wall with steel, and this significantly reduces the cost while at the same time increasing the strength. And we recognize that high-density polyethylene is very corrosion resistant. It's very abrasion resistant. In fact, it is the most versatile and widely used piping material in the world today. However, where it struggles is in structural integrity in larger diameters. The pipe wall has to be very thick. And Contech's experience with steel helps us realize that steel is a much better material for handling strength than thermoplastic. And for example, the modulus of elasticity, or Young's modulus of polyethylene, is about 180,000 psi, whereas the modulus of steel is 29 million. And this is not a mild steel. This is a high yield 80 KSI tensile strength steel that's used. And just to put that in perspective, regular corrugated metal pipe typically uses a 35 KSI steel. So it's a very strong, proven material used for the strength in this product. The polyethylene that's used is essentially the same plastic used in critical applications such as gas force mains. It is a pressure-rated polyethylene resin. It has an HDB rating attributed to it, or a hydrostatic design basis, and this allows us to understand exactly how it's going to perform over time under load. Many people ask, well, how do you get the steel inside of the plastic? And that's a great question. The manufacturing process starts out with melting the resin down and extruding it through a die to create a profile. And there's 3 different sizes of profile depending on the diameter of pipe that you want to make. Each profile has vertical legs, and the steel ribs are laced in between these vertical legs, and then an HDPE cap is fusion welded on top to fully encapsulate and seal the steel inside the plastic. At that point, the profile is wound onto a large spool, which can be stored, or it can be sent to another plant for manufacturing into pipe. And when it's ready to be made into pipe, we use a winding cage and a fusion welding machine. And we have individual winding cages for most of the diameters in 6-inch increments from 30-inch to 120-inch. And at that point, the profile is unwound off the spool. It enters the winding cage. The edge of the profile overlaps with the preceding edge of the profile, and it is fusion welded together to perform a very strong pipe wall. And this pipe slowly rotates onto a rolling table, and when the desired length is met, a saw engages from the bottom and it cuts the pipe to length. There has been an extensive amount of testing done on SRPE. It has undergone rigorous full-scale load testing at Queen's University by Dr. Ian Moore. It's had DOT, university, and third-party in-situ field testing performed over the years as well. And the results of all of this testing confirmed what we already suspected, and that is that SRPE is not a thermoplastic pipe from a structural standpoint. It behaves very similarly to corrugated steel pipe, and therefore it uses the same structural design methodology, AASHTO LRFD Section 12. The national standard for SRPE is ASTM F2562, but more importantly, the AASHTO standard is M335 for 30-inch through 60-inch and MP40 for 66-inch through 120-inch. Since 2007, millions of feet have been successfully installed across the U.S., from Canada to Mexico, from New York to California, including Alaska, Hawaii, and even the island of Guam. If you're working on a project that has federal grant funding, it's important to note that DuroMaxx SRPE pipe, as well as all Contech products, are sourced and manufactured in the USA and will satisfy the requirements of the Buy American Act. A few of the larger national agency acceptance would include the Unified Facilities Guide Spec, which different branches of the U.S. military utilize, including the Army Corps of Engineers, the Naval Facilities Group, the Air Force Civil Engineering Command, and NASA. It's also accepted by the FAA and has been used in major airports across the country, including underneath runways. It is also in the ARIMA Railway Design Guide and has been used under railroad tracks with Cooper E80 live load. So next, I'll pass it over to Andrew, but first, I think we have a quick poll question for the audience.
That's right, Justin. Our first question of the day is, in your experience, what is the most important factor for a successful project? Material cost, manufacturing lead time and availability, long-term durability and service life, or installation time and ease of installation? I'll give you some time now to mark your selections. And to submit your poll question, please click the answer on your computer screen and then click the submit button. I'll give you some time. And just a reminder, if you have a question, please type it in the question box and we will answer them at the end of the presentation. Looks like some answers are rolling in, so thank you for participating. I'll give you a couple more moments. Great, looks like most of you have answered, so thank you. And Andrew, it looks like 16% say material cost, 12% say manufacturing lead time and availability, 57% say long-term durability and service life, and 13% say installation time and ease of installation. Now I'll turn it back to you, Andrew.
All right, thanks, Jill and Justin. My name is Andrew Jenkins. I'm out of the Northeast region for Contech. And now we're going to talk about storm drainage and sanitary sewer as an application and solution with DuroMaxx. I have noted some of the questions that have already come through. Please keep sending those questions in. Those are great. And I'll try to address some of them as they're appropriate here in the next 10, 15 minutes or so. So DuroMaxx is a pipe and a conveyance solution in the storm water, storm sewer, and sanitary sewer world. So the big challenges are listed here on the left. I'm going to go through each one of them real quickly and how that is dealt with DuroMaxx. We'll talk about hydraulics, installation, joints, fittings, and Manway access. And for the most part, my examples are going to pretty much adhere to the sanitary sewer world and how DuroMaxx plays into it. Okay. Let's start with hydraulics. So, like almost all pipe materials in the U.S., one of the main facilities that tests for hydraulic capacity is over in Utah State, the hydraulic lab they have there. And the lab test supports the mains in value of 0.012. So we are a smooth wall interior pipe. And that is exactly why we've chosen the polyethylene and steel combination. The 012, and I think it's important for me to state this, stays that way in the initial and long term throughout the project or design life. And this is all because of the steel. As Justin pointed out, the steel is doing all the work. And the smooth, corrosive resistant, abrasive resistant polyethylene wall is just along for the ride, creating that smooth hydraulic interior. So the steel, being that it's extremely strong and doing all the structural work, will now allow the weaker thermoplastic to creep or the pipe as a whole will not experience a circumferential shortening like other non-reinforced polyethylene or polypropylene products. And therefore, it does not experience what we call an inner wall buckling, which could vastly change that mains end value. So very important to the sanitary and storm sewer pipe designs. Some folks were just asking, what are the competitors of DuroMaxx? And this is my slide to answer that, actually. So really, there's two primary materials out there. And you need to think of DuroMaxx not in that 8 and 10-inch collection sanitary world. It is meant for the Interceptor, trunk line, outfall type of solution. And really, the two main competitors we have in the industry are reinforced concrete pipe, as most are familiar with, and fiberglass products. And both materials, due to the very efficient and innovative way we manufacture SRPE, the compactness of the design itself, we are very competitive cost-wise, all the way from the 30-inch all the way up to 120-inch diameter. One of the other issues with large diameter projects is the installation, and we do get a lot of questions for those who are newer to steel reinforced polyethylene and DuroMaxx, and that is, does it have some sort of special installation requirement, or is there something new that we have to worry about? And the quick answer is absolutely not. No. We are using the same industry standard ASTM D2321, and as most, if not 99% of all installations for a large interceptor or trunk line, we're using the same class 1 type backfill materials to install it. ASTM does allow for a variety of different backfills that can be used for DuroMaxx, but we're very much just like everyone else. So if you're putting in a fiberglass 60-inch trunk line, we would be doing the exact same installation procedures. So comparing the three, concrete, fiberglass, and steel reinforced polyethylene, as of right now, we are limited to 120-inch diameter. We do have maybe goals to increase that into the future, but for the most part, some of the main things to look for here on this slide is the pipe length. We can go up to 40 feet because of our very lightweight product. As you can see, comparing the 60-inch example on a sewer project, concrete is 1,400 pounds plus. Fiberglass is around 200 pounds per lineal foot, and the DuroMaxx SRPE is only around 43 pounds per lineal foot. Another thing to note is how many sticks of pipe we can get on a truck. We do have the ability to nest the product, which means putting a pipe inside a pipe to ride, and really cut down on the logistic costs to the job site. All these things wrap up to a overall installed, very cost-effective solution. And this carries over into the next slide, which is talking about further installing in the joints. But the number of joints, how many picks you have to deal with, the lack that you don't need a crane to pick up the product, you can use your typical backhoe, all is a benefit for the installed cost. A good segue from the last slide to my next one is just talking about a major concern in the sanitary sewer industry, which is I&I. And again, because of the long length capabilities, and we do have custom links as well, but up to 24 and 40 foot sticks means we just have fewer joints per, for example, a 2,000 foot project. You can see almost half as many as fiberglass and a lot fewer joints as compared to concrete pipe. And this just means less picks, faster installation, less concerns about joints. And if you're talking about ultra large diameter and you have to do some sort of joint testing, fewer joints to test. So segueing into the joints themselves. For these conveyance applications, we have two primary joints that are available. The first one is our high performance joint. And again, because we know the strengths of steel and what the plastic is good for as well, and knowing the differences in their ultimate or structural strength properties, we have chosen to reinforce both the bell and the spigot with steel. So this is a traditional bell and spigot with a flexible gasket type design. And as you can see from the drawing, the steel is located in the seated area for the gasket and the bell, and underneath the gasket, which is very important for long-term integrity and avoidance of creep and other deformations, we also have chosen to reinforce with steel. So the joint meets and exceeds the industry standard joint test, which is ASTM D3212. And this joint is up to 72 inches in diameter. The other option we have is a welded coupler joint. This is a full 360-degree weld on both sides of a coupler that is a similar material, or matched material, I should say, to the pipe itself, and completely closes the pipe without a gasketed connection. As you can see, this gentleman here is welding an ultra-large diameter pipe together. This is very common in our large diameter underground storage systems, and Justin will talk about that in a little bit. But we have this option as well. And again, far exceeds the industry standard ASTM D3212. Very commonly asked about is what sort of fittings can come with this product? Well, one of the big benefits, along with the corrosion and abrasion resistance, is the ability to easily fabricate with polyethylene. It's very fabrication friendly, and we have a very versatile menu of options to form and fabricate with this product. So very customized fittings can be accomplished. Pretty much if you can dream it up and we can fit the welding gun there, we can build it. So full line of elbows, T's, risers, laterals, and bulkheads, etc. All of this is done at a state-of-the-art manufacturing facilities that we have in Montgomery, Alabama, and in Ogden, Utah. Another question we get asked very often is about tapping the product. Now, I want to remind you, DuroMaxx is positioned really for that interceptor, trunk line, and outfall application or solution. And there are very few, in fact, taps per mile in that design world as compared to the collection world of 8 and 10 inch. But when there are, we can use any lateral connection really that's currently available in the industry. As you can see in the bottom right, as well as above on the far right, welded tops, saddle tees, etc. Easy to sawzall the metal with an abrasive blade. We can also train crews and maintenance facilities that can do this themselves. This is an example of a group in Texas at a maintenance facility for a large municipality, welding it on and doing their own ASTM sledgehammer test to see how well they did. And they did pass. So minimal capital expenses are required to own or buy these things. Also, there are plenty of polyethylene welding contractors across the country that can perform these tasks as well. And then lastly, another challenge is Manway access. And this is a bigger challenge in the Interceptor trunk line world than it is in the collection world, primarily because the structures become so large due to the diameter sizes. And so whenever possible, we've been working with engineers across the country just to eliminate the concrete structures as a whole. And the first and easiest way to do that is to do just a polyethylene riser off of our pipe. They can be fairly large in diameter for easy and comfortable access. They can be fairly tall as well. And we have a lot of different design options for that application or solution and details to come with it. If there are issues and a concrete rings are needed or required, we still have a couple solutions where we don't necessarily need to cut the pipe, meaning we can maintain a very smooth hydraulic invert from inside to out of that structure. We can either pour a base and then do rings above, or we can even do what's called a doghouse type of solution, which you can see in the bottom left here. Either way, we have some versatility. And then when a boot or a compression style gasket is required to add a structure, we can do that with an adapter. Obviously, we have a exterior rib product, so we can do a solid wall polyethylene adapter that would be booted upon or pushed into the manhole to make that transition. Now for just a couple of slides on real life examples. The first one I'll point out to is a sanitary sewer interceptor near the Grand Tetons in Idaho, excuse me. And this is well over 50,000 feet of DuroMaxx. It's been well over 10 years now installed, performing wonderfully. It primarily was 48-inch with some 42-inch and some 36-inch, 10 plus miles of pipe. This was all installed in around 20 feet deep. The contractor was able to use the in-situ soils because they did meet the criteria required by ASTM 2321. And all of it was air tested, low pressure air tested, and monitored for its shape. Just a great example of 10 miles of Interceptor installed and has been proven performance for over a decade now. And just to kind of talk towards the structural aspect, I included this project here where I'm located. This is with the Ohio Department of Transportation, and it was involved in an intersection with a major highway of Interstate 71 and just off of downtown Cincinnati. This had installation depths up to around 40 or so feet, which was accomplished with a combined sewer, a new combined sewer with 30, 60, and 72-inch diameter DuroMaxx. Again, combined sewer needed a corrosive resistant and a competent joint, so DuroMaxx was chosen for this. But there was also some portions that exceeded 44 feet. And we were able to provide the engineers a candy analysis showing that it did check up to 59 feet, but for just good measure, we did utilize a 72-inch CMP as a casing pipe, and the DuroMaxx was just run through that as a casing carrier. So just a great example of the depths. Are published height covers on the literature that you can get on our website are conservative estimates. If you are on a project and you are getting close or exceeding those height cover recommendations, please just contact Contech and we'll run an analysis and talk to you about your job one-on-one. So as Justin was talking about why we made the product the way we did, and I was going through the storm sewer and sanitary sewer applications, as we launched this product and grew the diameter set, we realized how versatile the product is. And there are so many other applications that DuroMaxx is being used for. And Justin's going to touch upon the underground storage applications next. And I believe we have a poll question, or maybe not, that's for later. So I will pass it on to Justin.
All right, thank you, Andrew. So as designers, we're all familiar with NPDES, the National Pollutant Discharge Elimination System. And more importantly, we should be very familiar with the regulations in our specific areas. And as I mentioned earlier, Contech manufactures BMPs to treat stormwater runoff for things like hydrocarbons, trash, debris, floatables, to get those pollutants to an acceptable level where it can be discharged into our storm drain systems. However, there are certain chemicals and pollutants that should not be released into the storm drain and make their way to streams, rivers, and coastal areas. And the EPA has identified many of these targeted contaminants. And a few examples would be sanitary sewer overflows, combined sewer overflows, glycols at aircraft de-icing facilities, as well as AFFF fire suppression. AFFF is aqueous film forming foam. Also oils at substation and transformer yards, pulp and paper industry, industrial processing, including computer chip manufacturing and data processing, as well as fueling and washdown areas. And many designers will choose an option to route these flows into an underground containment tank, and then they can be released at a controlled rate to a wastewater treatment facility or pumped out and sent for further processing. The traditional design for these tanks would include concrete vaults, smooth welded steel, or fiberglass tanks. And today we'd like to make you aware that there is a more cost-effective option than these materials, and that would be SRPE underground containment tanks. As Andrew mentioned, they are highly corrosion resistant to many different chemicals, as well as resistant to alkaline or acidic soil environments. I would like to point out, if you have a design and you're curious about the chemical and how SRPE would react to it, I would encourage you to check out the Plastic Pipe Institute's technical report number 19. It has a lot of good information on the compatibility of different types of plastic with different chemicals. Some of the features and benefits of SRPE underground containment tanks, as I mentioned, they are very cost competitive with fiberglass, concrete, and smooth welded steel, not just from a material standpoint. If you look at this compared to a concrete vault from an installation standpoint, there is considerable time savings and cost savings when you take into account building forms, tying steel rebar, pouring, curing, stripping, and waterproofing. All of this adds up. We talked about the chemical resistance of polyethylene, and it is also very customizable. As Andrew mentioned, it's fabrication friendly. We can accommodate tight or complex job sites by using T's, Y's, elbows, manifolds, lateral stub connections, risers, just about whatever you can think of, we should be able to fabricate it out of SRPE. As well, it is a watertight system. We manufacture single tanks that are self-contained and would not require any field welding, such as the picture in the upper right. And these would be 15,000, 20,000 gallon capacity tanks. However, because we can field weld these tanks, they can get as large as is needed to multiple millions of gallons. The picture there at the bottom is the installation of a glycol contaminated runoff system at the Memphis airport, and it's 2.68 million gallon capacity. They also install very quickly. There's no crane needed. Typically, the local contractor can install with their usual equipment. And because it is designed with steel as the structural member, it can accommodate heavy live load and high cover. Most designs would incorporate an access riser at the upstream and downstream end for easy inspection and maintenance. The smaller tanks, we can perform a low pressure air test at our plant to make sure that they're fully sealed. We also do spark testing because we want to make sure any cutting and welding that we do is going to be watertight. And if you're not familiar with spark testing, it involves taking metal tape and placing it on one side of the weld. Then we go to the other side of the weld with a spark gun. And this gun emits an electrical current, and that current will find its way through any fissures or small micro passageways in the weld and make its way to the metal tape. And it emits a very visible and audible spark, and we know to seal it up right there. So we do spark test all the welds on our tanks. An application that I'd like to point out is sanitary sewer overflow. Many municipalities have issues with I&I, as Andrew mentioned, inflow and infiltration. During a rain event, it inundates their sanitary sewer system, and in some cases, it bubbles out the tops of manholes, which is a real problem. One solution for this is to incorporate an underground containment tank or expansion tank. These are typically located at a pump station or lift station or at the wastewater treatment plant itself. But they can be located anywhere along the system where there's room. And what this does is it gives the effluent somewhere to go until the rain event subsides, and then it can be released at a controlled rate to the wastewater treatment facility, usually during the low flow hours early in the morning. In regard to the chemical resistance of SRPE in this application, whenever you stagnate sanitary sewer effluent, the bacteria become active and they create hydrogen sulfide gas. And this gas has a reaction at the surface which forms sulfuric acid. And this is obviously detrimental to the cement and concrete. So for systems that have these types of problems, the concrete pipe or concrete vault should definitely have some type of protective coating to protect against microbial induced corrosion, or MIC. Another thing that we want to look at when we're dealing with a watertight underground tank is flotation. We may need to introduce some type of counter buoyancy system. We have many ways to do this. A common way is to use a high capacity nylon strap system that goes over the tank and is connected on each side with a mechanical ground anchor. These could be helical anchors, or they could be a load locking type of anchor such as platypus or manta ray, or you can use a concrete ballast anchor or dead man anchor. As well, another option would be to use a CLSM over the top of the tank for backfill, a controlled low strength material. In my opinion, the best way to prevent flotation of a tank takes place during the design of the tank. If you can incorporate enough cover over the crown of the tank, you can ensure against flotation. We offer a lot of information in regard to this. We have developed a table that shows the minimum cover needed to prevent flotation for the different diameters of tank. And this is really a worst case scenario. We assume that the tank is completely dry and empty on the inside, but that it has been fully surcharged or is in a groundwater condition where the elevation is above the crown of the tank and the soil above the tank is saturated. For example, if you have a 120-inch diameter tank, if you can design at least 5 foot 5 inches of cover over the top, then it should not float. In regard to the inspection and maintenance of these tanks, I mentioned typically we'll place a riser at the upstream and downstream end of the tank. And this makes it very convenient for the inspector to pop the lid and look down and see if there's any occlusion at the outlet. And also we can provide ladders for easy access down into the tank if needed. As well, these can be pumped out, or a jetted hose can be used to spray it out. And the rounded bottom of these tanks is very conducive to promoting flow towards the outlet, especially when you compare it to the flat bottom of a vault type system. I would like to share one real world tank example. This particular project is out west at Camp Pendleton Marine Corps Base in Oceanside, California. And about 10 years ago, they were doing some upgrades to the Naval Hospital there. And they had designed a subsurface containment tank in the event that seismic activity damaged their wastewater treatment ability. And they had originally designed a concrete vault, but they ended up using a 120-inch diameter DuroMaxx system. This system was installed. It was subjected to a 24-hour hydrostatic leak down test and passed. And it was really a great solution because the DuroMaxx was much more economical than the originally designed concrete vault. In fact, just the waterproofing alone for the large vault was almost as much as the entire DuroMaxx system. And that's just from a material standpoint. You can see in the middle picture, the installation was very quick. That's a regular track hoe lifting 120-inch diameter tank section. So now I'll pass it over to Ryan to talk about some of our trenchless structural reline solutions. But here is our final poll question for the audience.
That's right, Justin. We have one final question for you. Which of the below types of projects are you most familiar with? A. Gravity sanitary trunk lines. B. Large diameter storm conveyance. C. Underground storage and containment. Or D. Reline and failing pipe and drainage structures. I'll give you some time now to select your answers. We have some really great questions coming in, so if you have a question, please type it in the question box and we will answer it at the end of the presentation. I'll give you some more time. Looks like a couple of you have answered. Thank you very much. To submit your poll question, please click the answer on your computer screen and then click the submit button. Just in case you forgot, there's the instructions again on how to mark your answer. I'll give you a couple more moments, and thank you for participating in our poll questions today. It greatly helps us. Well, it looks like most of you have answered, so thank you very much. And Ryan, it looks like the answers are 24% say gravity sanitary trunk lines, 36% say large diameter storm conveyance, 27% say underground storage and containment, and 11% say reline of failing pipe and drainage structures. Now I'll pass it back to you, Ryan.
Thanks, Jill. Good morning, everybody. We're going to spend the next few minutes talking about reline solutions, and more specifically how SRPE or DuroMaxx is used in these applications. We had a couple questions come about, hey, would this be used for HDD or pipe bursting? No, it wouldn't be good ideal for that, but it would be very ideal for sliplining, and that's what we're going to be focusing on here. We've done a few slipline webinars before, and we're going to always start with why would you look at that versus total replacement? And it's rarely an economic reason. Most cases, there are extenuating circumstances that would actually cause more pain to the populace. So if there are long traffic disruptions and detours, lots of utilities, that type of thing, that's when sliplining becomes very ideal for people to consider instead of just ripping up and replacing. If you remember the webinars we've done in the past, we've always pointed out the 7 critical design construction considerations. We're only going to focus on 2 of them here, and these are the 2 that generally raise the most questions in terms of installation, but also in design. If you want more information on the other 7 and how SRPE can handle all of those, we'd be happy to address those offline. We're going to focus first on hydraulics. And the where people get into trouble with hydraulics is there's a lot of thought out there that because you're improving the Manning's end of the pipe by sliplining, you are improving the hydraulic capacity. And that is true sometimes, but it's not true all the time. So if you're sliplining a culvert and it's in inlet control, the Manning's end doesn't come into play. The only things that on inlet control culverts that come into play from a hydraulic capacity perspective are the inlet geometry and the inlet size. Anything else, pipe smoothness, does not come into play. Conversely, if you're looking at an outlet control culvert, or if you're looking at a sanitary sewer system or a storm sewer system, that's when you add the considerations of pipe slope as well as Manning's end. So diving a little bit deeper into inlet versus outlet control, you heard me say that or allude to the fact that no matter what, if you are sliplining a culvert that is in inlet control, you are reducing the hydraulic capacity of that structure, no matter what. Doesn't matter what system you're using. It doesn't matter what the Manning's end is. So how do we overcome that? There are a couple ways that we can reduce the negative impacts, and they all focus on the inlet geometry. Most culverts have projecting fills, and that coefficient that you see are focused primarily as a 0.0 or 0.9. But we can decrease that negative effect by using a flared end section like you see in the picture in the upper right, or a a beveled ring. That's one of the best. In some cases, we've been able to actually use an increaser at the inlet end. So even though our liner pipe would say be 30 inches in diameter, the inlet itself would be 48 inches. And there, because we're only concerned about the inlet, we're able to increase the diameter of that inlet and potentially increase your hydraulics. Now, the one drawback with that is you do have to have a little more right of way and able to use this structure, because you've got to extend that out further in order to get to the larger diameter. Moving on to outlet control, or even storm sewers or sanitary sewers, we have a few things here, and basically what we're looking at is a comparison calculation. So what we're doing is we're taking the Manning's end of the existing pipe and the liner pipe along with the respective diameters, and this calculation will determine what the percent of existing flow is. So because of that, what we see below the line are some comparisons on a project that we had in South Dakota. So the first one is Sliplining a 24-inch CMP with 21-inch A2 liner. This was in outlet control, and we were able to increase the flow by 112%. So on a larger scale, same project, we had a 96-inch structural plate that we were sliplining with 84-inch diameter DuroMaxx, and that we were able to increase the flow by even more. So these are things that we can do to help you from a hydraulic perspective if the information is known. Moving on to more of an installation related question, and that is grouting and flotation. We get a lot of questions about whether or not the void between the old pipe and the new pipe should be grouted, and the answer is unequivocally yes. The purpose of the grout is to hold the liner in place, but it's also there to transfer loads between the liner and the hose pipe. So the trouble comes when you try to use pressure when you're grouting, and too much pressure can cause problems like you see in these pictures. And we clearly want to avoid those. So how do you do that? There's a lot of means and methods here, but one of the best ways to do it if you have easy access to water is to fill the liner pipe with water prior to grouting. So that will basically act as an anchor in the pipe and hold it in place, especially if you're using a lightweight grout. And we'll talk about that in another couple slides. If you don't have easy access to water and the liner pipe is enterable, so you can enter it, we can actually pre-install grout ports. If you look at the picture on the right, you can see the white dots. Those are grout ports that are pre-installed at the plant. Here they're at the 5 o'clock and the 7 o'clock position, and they also have one at the 12 o'clock position. Those are going through the pipe wall and bracing against the liner pipe crown, or the hose pipe crown. And essentially it's holding down the liner pipe while the grouting process occurs. In the detail on the left, you can see that the grouting is done in lifts. So you're not doing one giant grout, you're doing two or three different lifts based on the grout density and the slope of the pipe and pipe diameter. We can help the contractor with that. The other item is the grout itself. Ideal grout properties that we're looking for compressive strengths of 50 psi to 300 psi, depending on liner diameter. We also don't need a large density. So we're looking for actually a lighter density, anything lower than water. Remember, we were talking about filling the pipe with water, or even if we have to use bracing, the lighter density, the less buoyant forces you're going to see act on that liner pipe. So we're looking for something that is a spread versus a slump. And the other thing is, to do that, a lot of entities will use some admixtures, and a lot of times that can increase the heat of hydration. We need a heat of hydration that's less than 140 degrees Fahrenheit. So we do get asked a lot whether or not we have sample mixes, and we do. But a lot of the times it's best to talk to the local grout suppliers because they already have a mix that's ready to go, and they're going to be able to help the contractor and engineer with that. The other last point I'll bring up in grouting and flotation is how do we get the grout inside that void between the hose pipe and the new pipe? And there are a lot of different ways. The two major ways are, if you look at the picture on the left, we're looking at what I call grout tubes. So this is at the inlet end, and there's a bulkhead with grout tubes placed inside. And those grout tubes are of various lengths. So if this run was, say, 300 feet, some of the grout tubes are 250 feet, some of them are 150 feet long, and that way the contractor can send the grout down the tube and get it to where they want to as they're able to continue the grouting process. The other way, and this is used primarily in larger diameter reline applications, is actually using those grout ports I pointed out before. The contractor can tell us where they want those installed. We will send them out to the job site pre-installed, and then the contractor will just hook up their grout hose directly through those grout ports, and then they'll be able to insert grout wherever they want to. A good, I guess, sense of warning is try not to have the contractor push the grout uphill. You want gravity to do the job, so you want it to flow downhill instead of you pushing it uphill. That's going to decrease the pressure that's acting on the liner pipe. So before I turn it over back to Justin, I'm going to do two case histories. The first one is an airport. You heard Justin mention the airport funding, and there's a lot out there. We do a lot of sliplining on airports. You can imagine, especially in this case, we had a pipe that was under 24 feet of fill under a taxiway. You can imagine the trouble that it would be to, one, close down a taxiway, but two, unearth the existing pipe under 24 feet of fill. So instead, we were able to reline it using a 54-inch diameter DuroMaxx. That was done in 2016, and it was one run that was just under 400 feet long. The next project that I'll talk about is down in Florida. Those of you who are in the Florida area or work with Florida know that the I-4 project that they are doing has been going on for quite a long time. And this is just a small part of it, but what they had out there was some cracking concrete pipe. And what they needed to do was either replace that pipe or they needed to slip line it. And you can imagine, take a look at the picture on the right-hand side. You can imagine there's an MSE wall going right over the top of this pipe. Exhuming an MSE wall is a big challenge. So it would almost be impossible. You're far better off to just reline the pipe and then grout the void in between the two. So that was the approach that they took for this project that they were able to do back in 2021. So from here, I will hand it back over to Justin to wrap things up. Justin?
All right. Thank you, Ryan. Yeah, so in conclusion, I would just like to take a moment to share some resources that we have for you. We went over a lot of different bits of information today, a lot of different applications for the SRPE technology. If you would like to find out more details, I would encourage you to check out our website, contechES.com. Our website actually has more information geared towards designers than any other company in our industry. This would include things like DYO, or design your own tools. We have these available for reline, stormwater, and bridge. We also have a very voluminous technical file with different documents such as specifications, standard details, and things of that nature. We also offer PDH articles where you can select a topic, read about it, take a short quiz, and gain a PDH credit. We also include many project examples that you can look at, as well as blogs. And we even have a local resource tool where you can identify your local Contech expert. I also want to point out something on our website, specific to a lot of different product technologies we make, but primarily SRPE, and that's our what we call PDW, and that's Project Design Worksheet. And this requires less information to fill out than the DYO, and it essentially forwards the information to the appropriate engineer, and then we will contact you with specific recommendations and assistance. And we have these on our website for steel reinforced polyethylene used in sanitary, storm sewer, containment tank, and reline applications. And finally, I would just like to emphasize that Contech is a free resource. We are here to work with contractors, engineers, and owners on their civil projects. We can offer design ideas, CAD-based proposal drawings, budget level estimates, and even job site assistance. So I would encourage everyone to find out who their local expert is with Contech and get to know them. We're happy to help. And with that, I want to sincerely thank everyone for your time. Thank you for attending. And with that, I'll pass it over to Jill, and she can open it up for questions.
That's right, Justin. If you have a question, type it in the box, and we'll get to them now in a couple minutes, in the few short minutes that we have. Our first question is, how much cover can DuroMaxx pipe handle?
So again, DuroMaxx follows the same structural design methodology as corrugated steel pipe. So it's quite a bit. The cover ranges from 25 feet max to over 50 foot, depending on diameter. And as Andrew mentioned, the published values for our maximum cover are quite conservative. So if you get close to that number or go over it, I would encourage you to reach out to us, and we can take a deeper dive into the structural calculations and see if we can accommodate your load.
Thank you, Justin. Our next question is, how is DuroMaxx UV protected?
The resin that we use for DuroMaxx has 3% carbon black, which has been shown over decades of use to provide over 50 years protection against direct exposure to sunlight.
How about, can stubs be attached to DuroMaxx in the field?
Andrew, do you want to speak to that one?
Yeah. Like we are saying, you know, the short answer is DuroMaxx is just like the other products. One of the caveats, though, for example, if you're comparing it to, let's say, fiberglass, typically fiberglass has to send out their own folks to glass a connection on a field installation for a lateral or whatever coming into a main line, whereas the maintenance crews or a nearby certified welder could do it for you. But there are a couple different options we have as far as welding in a stub, or even purchasing a readily available self-tap that is supplied in the industry, can all be achieved. And we have a couple different details and or can walk you through or the contractors through those sort of scenarios as they come up. I hope that answers that.
Thank you, Andrew. Our next question is, what is the largest DuroMaxx tank size?
I can answer that. So we can manufacture standalone tanks that do not require any field welding. And the largest one would be 120 inch by 40 feet long. And the volume would be around 23,000 gallons, or a little over 3,000 cubic foot. Larger tanks are certainly possible, but it becomes a logistics issue. And the field welding on the tanks, I just want to mention, is done internally. And the benefit there is it allows the contractor to immediately install the pipe or tank and backfill it. And then the welding is done after it's in its fully loaded condition. It's all done from the inside. But as far as the largest single tank, it's about 23,000 gallons.
Do we have time for one?
I did see another question, just to note, to not confuse anybody. Another question was a little different, but I think they were asking what was the largest not this question you just read, but another one was, what's the largest underground system you've done? And we've done millions and millions of gallons of underground storage using DuroMaxx on a single site on a single project. So just want to point that out.
Well, thank you, Ryan, Justin, and Andrew. And thank you, everyone, for participating in today's webinar. If your question was not answered, a Contech representative will reach out to you with a response. Don't forget to register for our upcoming webinar coming up in May. Our survey will appear once we conclude the webinar. Please complete the short survey to receive your PDH credit. A follow-up email will be sent that will include a link with instructions on how to download your PDH certificate. That concludes today's webinar. Thank you again for joining us and have a great day.